Well, welcome to our structural modeling video conference for August of 2017. Today we're going to be talking about the local attributes of the structural relationship. This work that we're talking about today is kind of a culmination and based on some of the work that we've done over the last year or two. And it's interesting to note that in August, this particular broadcast is the third year in a row that we've done a monthly video conference every month, except for I think we didn't do 1 month when we were at a Ancosi conference. So essentially, this has been going on and with the help from the people in the community, and it's building a fairly large body of knowledge and information about this specific area. And I'm kind of excited actually about this work because what I've done, because of the way that I've organized the information that's been developed in the past for the last 3 years, I developed a new website. And when I went through and looked at the website and reorganized it so you could access the information better, it just became clear to me that we have really developed a lot of work, and it's been quite interesting, these different areas and different ways we've gone. So we're getting kind of close to changing maybe the approach or the packaging of this information a little bit, maybe put it in different types of groupings, group the text with some software, make it a little smaller, type of more bite-sized type of things that we can look at. So we'll see how that goes. But anyway, for this month, we're going to be looking at the local attribute of a structural relationship. And we're going to do this in the context of the other logical properties and logical attributes that we've developed and talked about for the structural relationship over the last year or two. This type of approach and developing these attributes and properties then allows us to speak more specifically about individual relationships and how they're the same and how they're different. So this part right now is what we're talking about in the logical relationships. When we look at the systems structuring relationship in the classical literature, you find that Warfield really only listed in prose 5 of the logical properties for a binary relationship, and that was reflexive, irreflexive, symmetric, asymmetric, and transitive. Those are the ones that he gave. And then when you analyze the graphics, the structured graphics that go with the work that Warfield published, you'll find that there's actually 2 more logical properties, which are non-reflexive and non-symmetric. And we list the references to those, where the figures are, and where you find those in Warfield's work. So that's really a foundational piece. And one of the things, of course, with Warfield's work is you assume that most all the relationships were transitive. And so that's why we don't have a non-transitive or intransitive listed here from Warfield's work. Mary and I developed the augmented model exchange isomorphism, which has 27 groups of logical properties, and we use those to categorize the a specific relationship. And one of the things that we've found in looking at this and working with the AMEI and thinking about how we can classify and get more information and better information about a relationship and how to handle it, is that we this idea of degree of focus, or whether or not a relationship is, let's see, yeah, the degree of focus, and whether or not it's dispersed or specific. Now, a specific relationship will fit in one of the categories, one of the logical categories, like equivalency or is equal to. That will go in a reflexive, symmetric, and transitive bucket. So that relationship itself, equivalence, will fit into one of the logical categories. But a natural language relationship like is connected to is dispersed because it maps to all 27 of the logical property groups. And as a matter of fact, that's the logical property that we use to demonstrate in the AMEI and is encoded in the AMEI document. So when we're looking at structuring relationships from a natural language standpoint, and we're developing these attributes and properties that we're going to use to classify and make distinctions between these different groups, then the idea of specific and dispersed is put in the context of a degree of focus on the AMEI chart. It becomes an important tool. And here's a chart that kind of details what I just talked about with the different logical properties as Warfield outlined them. So the Warfield prose compatible property combinations. Basically, these are the logical properties that he wrote down in prose. And then the blue are the structural graphics compatible, or these are the logical property groups that are congruent with the structured graphics that he presented. So that you can see there that the first column, all the ones with transitive in the group in the first column are all covered. So it's 9 of them, I believe. Yeah, 9 of them here. So then, but the intransitive and the non-transitive were not addressed by Warfield's work. But we added the non-transitive and the intransitive because it's important to have a complete set of categorizations to clearly communicate and reduce uncertainty about the communication. So we've completed this set. All right. So another relationship attribute that we're working with is the local and global. And local and global is something that I think has a lot of potential for us to develop and to be very useful as we develop common understanding of what these attributes mean. And in general, a global relationship is a relationship that has a mediating type of artifact that's used in the relationship between the two objects. And a local relationship is a relationship that applies directly between the two objects without a mediating artifact. So this has some fairly interesting, this has a fairly interesting impact when we're doing analysis of the relationship. First of all, when we have a global relationship, then we have information about the mediating artifact and how well that information is shared among the people in the group. Because in ISM, we're using people as our sensors, we're using people to get the information from. And so if people have a common set of experience and they have a common understanding of the mediating artifact, then that has a tendency to make things more explicit and to make things easier to understand with less effort, because that common understanding is already there. But in the global systems, of course, there's a range. There's a graded range of how well we understand and how well we share this common knowledge about the mediating artifact. For example, with gravity, we're saying, well, object A is heavier than object B. Basically, that's facilitated by force of gravity on the Earth. That's something that most all human beings have a very good understanding of, and how that works and how it can be utilized. So it's a common artifact. We have measurements, we have a common way of thinking about weight, symbols, metrics, and so forth. Then with geometry or positioning, global, well, I would say spatial positioning is something that most all human beings are very aware of, and you can have a lot of information about spatial positioning. We have a lot of developed language, we have a lot of developed metrics. So again, that's not a global type of relationship set. With spatial relationships, we have a lot of common information about. So these relationships that have global attributes are very valuable because of all of the common information we have. We shift over to a local system structure and relationship, then we don't have as much information, if any, really, about what those specific interactions are between the objects prior to getting into the event of actually starting to figure out, we say, if object A aggravates object B. Well, we don't have any history on that, or not everyone does. Maybe some people do, and that's what the event is about, is to find out, oh, okay, what information do we have? How do these objects interact with each other? And how can we actually use this information to effectively plan some type of better or higher value future? So these concepts of a global relationship and a local relationship help us to start to categorize, understand, and communicate about different types of relationships. Okay, so we're looking at how these relationships have been used in the past with the different artifacts and the different methods and associated with structural modeling. We find that there's an interesting approach, historical approach. And what I documented here was the option field methodology. And essentially, there's a series of steps that you go through, and these are documented in the Science of Generic Design, and I believe also in the handbook and in other publications. But when you start out, you do a triggering question to the group, and the purpose of the triggering question is to actually develop the objects, or select the objects that are of the system that are going to be structured. So first we use a triggering question to identify and document the objects that we're going to be working with. Then we use a series of generic questions to structure these objects that were identified using the triggering question. And so this kind of is, again, another clear separation between the methods and processes that are used to identify the objects in the system and the processes and methods that are used to structure the objects in the system. So we have going through this process, and we use one round of triggering questions to develop the objects that are going to be addressed, but you can have multiple rounds with a generic question. And looking at the classical information on how this was done, there's appears to be an interleaving in these generic questions of relationships of relationships that have global attributes and relationships that have local attributes. So this is, to me, was interesting how this interleaving was done. And is there an advantage to doing this interleaving? And I believe there is. So that's just basically what we would look at as we're going through and talking about what's been done in the past and what is basically available in the literature. The local attribute has some interesting ideas and has some interesting concepts associated with it that we really need to think about. And these are just some questions to kind of get us thinking about the character of a local attribute, or the character of a relationship that has a local attribute. And the first one, of course, is, does a relationship with a local attribute impose a sequence on all the objects? Which is interesting to me because most of the global relationships with global attributes that we've looked at so far do impose some type of order or sequence on the objects. But it doesn't appear that a local attribute does that. And of course, the local attribute does not require transitive logical property. And the local attribute doesn't have to apply to all the objects in the system. I think this is a key factor, because you take something like weight, you have a number of objects, a global relationship, like heavier than, well, all of those objects are going to participate in the gravity field. Some are not going to be outside the gravity field. It's global. Everyone's there. So it really applies to all the objects in the system. So if we say, is object A heavier than object B? Well, yes, but then it's also, though, it has a relationship of heaviness to all the other objects in the system that you're thinking about. Whereas in a local system, that's really not true. And this global application of a global relationship then tends to create sequences and all-encompassing structures, whereas local attributes, you don't have to do that. So I gave a fairly simple example here of aggregates with a few steps. And let's see, now Where did I do that one? Oh, right here. I just talked about a building that had a do not occupy status. And second, the building roof leaks. Third, the building plumbing leaks. Fourth, the water supply of the building's turned off. And fifth, the building has broken windows. So these objects can aggravate each other. It's in one sense. But in another sense, these attributes also, or these objects, kind of eliminate one another. Because if the water supply to the building has been turned off, yes, that definitely aggravates the do not occupy status, but it eliminates the building plumbing leaks. And so there's these other types of logical interactions that need to be considered among all of the other objects in the group when you're using logical approaches. And this also would seem to create a scenario where we really had to look at a lot more questions and had to do a lot more detailed work in figuring out if we're on the right track. So if the goal is to reduce the amount of effort and reduce the resources that are necessary to do that, then it is important, I believe, to make sure that all of these issues are recognized and addressed in some way. And let's go back up here and look at the existing examples of a local attribute from the literature. The ones that we came up with were, so again, aggravate. So in the context of future effectiveness of computer sciences, does issue A significantly aggravate issue B? Okay, that's an aggravate one. And then suppose we're able to implement statement A, will this help significantly in implementing statement B in the context of an improvement plan? So both of these statements have a context, and one is significantly aggravate and the other is help significantly in implementation. So these are two local attributes. These are two relationships that have local attributes. And three, of course, is to make progress in addressing cause A. Will that significantly help cause B? That's a local relationship or a relationship with a local attribute, but it's not, it doesn't have a context statement. And then the fourth one was, does anticipated problem A aggravate anticipated problem B? Again, it's a relationship that has a local attribute, but it doesn't have a context statement. So some of the statements we got from the literature are bounded by context, others are not. So again, the thing we talk about here is the idea that aggravate is negative. And with a local attribute, it only goes between two objects. So it doesn't have to aggravate every other object in the group. It has to aggravate at least one other object, however. So this is kind of some of the structural and conceptual differences between these types of relationships. And what we're doing here is we're looking at these qualities and characteristics of these structural relationships so that we can categorize and group these concepts, these structuring concepts, and then apply common methods and practices to them. And I think that the local and global is definitely two different categories of structuring relationships that will have two different types of approaches. We talked about the negative, we talked about the building, And then, of course, we talked a little bit here about what each one of these are and why they might take more effort and more work within the group to make sure that you're on the right track and you're getting the quality of information that you need when you're using a system structure and relationship that's local. So went through and talked about a number of these things, but what we have happening, I believe, and the most interesting thing, was the sequencing of the questions that were documented in the literature, because the generic questions can be sequenced in a way that first you start with a relationship that's global. In many cases, what we see is that first one is going to be a categorization and grouping. So we'll say, for example, I have a problematique and we're trying to discover and organize the structure of the problems that we're facing. So if we take those problems, and then the first generic question that the group might go through is categorizing those problems. Oh, are they the same or are they different? Right? So that's a general, let's say, global type of attribute with categorization. So that starts off by using a structuring relationship that is global. Then you can either go to a generic question that's organized around a relationship that has a global attribute or has a local attribute. And what I've seen from the literature is usually you have a global type of generic question or a generic question based on a local relationship. Then you have a generic question that's based maybe on a local relationship like aggravates. And then you have a couple of more questions after that that are based on global relationships. And so those are, that way you kind of sandwich the local or the generic question with the local properties, you kind of sandwich that in between two global ones. Now, what this appears to do is it appears to start with categorization and finding common elements at first. Then it talks about the interaction between all of the individual objects. And then after you've done that, then the next set is when you arrange those objects on some type of ordered timeline or ordered precedent or some type of ordered structure. And to do that, then you use a relationship with a global attribute. So out of this, I think that we're approaching enough metrics and properties and attributes of the system structure and relationship that we'll be able to define this better, communicate about these things better as we go forward. So I think that that's essentially what we have with this particular technical report today. And the summary and conclusions, of course, is that we need to continue to develop and refine the characteristics and attributes associated with structural relationships that are used to structure the system. Need to think about the effectiveness of how you would sequence these particular questions and why you would do that. How would that help? Would it would reduce the amount of time and effort it takes to get the people involved in the process on the same page? Would it help create common context, because really ISM, from my point of view, is a tool, a structured tool that's used to get a large dispersed group of technical experts or people that are experts in certain fields in the problem that can't see the whole problem, bring them together and to start as a group determining what the structure of that problem is. And then how can they kind of start solving it a little bit. So that to be able to quantify this, though, we need to make sure that we continue to develop and get consensus on these types of attributes, characteristics. So with that, are there any questions?
Well, yes. Lots of questions. I'm getting a little echo here. Anyway. This generic global, local, global sequencing.
Yes.
I'm wondering if there's any way that you could present a specific example of that. Because it's obviously quite crucial that the initial framing question is of crucial importance to the whole structure of business. Sensitivity to initial conditions is crucial. So I think that's question one. And the second question relates to design thinking in today's contemporary language, where we're actually doing some design, and the solution to the design may not exist in the structuring. It sort of transcends. Good design goes beyond the brief, if you will, or the question, and I'm questioning how to address that. So there's a
Yeah, those are two very interesting questions, Peter. I think first, there's documented sequencing within the literature. I think the Science of Generic Design in the handbook. But I'll take a note to specifically distribute pointers to where those examples are. But and in reading those examples and looking at them, I agree with you 100% that essentially what is happening in my mind anyway is that you sequence those questions in a way that it helps the people in the group develop common context so they can go to the next phase. And so I think what we really have to understand and kind of I've been grappling with a little bit is really that what we're trying to do here is rapidly bring a large group of individuals up to speed quickly on a problem that's bigger than all of them can see. So how do we do that? How do we help these people communicate in a structured manner without simplifying it too much, but without expending too many resources? Because you can overload every individual. So what you want to do is you don't want to overload each one of the individuals, because you could overload everyone with information these days. So that's something you don't want to do. What you want to do is you want to be able to identify what are the crucial points and then explore those crucial points in a kind of a graded fashion. And then keep pulling those threads down that track until you get to an acceptable solution. So with ISM, there's four types of solution endpoints that are acceptable. So there's not just one. There's a wide range of acceptable solution endpoints. The real key factor in my mind now is that we need to understand what, how can we really, we need some feedback from the group, okay? And so I think this is where the psychologists and the sociologists and those types of people come into play, okay? And for example, let me just digress a minute, because I think this is kind of where we're going to go next. And there's some information that's already developed. And this is the area of utility theory and natural monopolies. Now, utility theory is pretty much an idea of taking and monitoring or measuring a person's value system for utility. And so everything we're doing with ISM is we're saying, yes, we have a problem, and this problem is important enough to the organization or to spend resources to fix it. So that is a general value system that's been made, or you wouldn't even get into the ISM area. You wouldn't even get there. But once we're there, we're now in the idea of enhancing value and increasing value. And so how do we measure the fact that we're actually adding value or increasing value? Well, if we look back at, again, some of the classical literature, let's say on utility theory, there's some very well-developed ways that you can measure people's risk aversion, their value that they apply to different aspects of the context. So that's pretty well known. I'm not quite sure if there's something like this for a group, and it's an area that needs to be explored. But the other part then is to say the feedback loop is how do we look for, after we get some information, let's say we perform an event, right? Like one of these events, we do a triggering question, a generic question, go through and do everything and map it all out. And then we feed that information back to the group. And so now, how do we determine whether or not we should go to the next step or just call it quits? Say, oh, we got valuable information here. We think we can go forward or not. Well, no. Say, no, we didn't get valuable information here. It just dispersed. We didn't get any consensus, so we need to do something else. So, to me, those are aspects of this process that are just not clear. But I think that developing those types of metrics and those procedures would be very valuable. And I think now we could do things like that because of the ubiquitous availability of very high-speed telecommunications, like we simply didn't have in the 60s and 70s when this was developed.
Oh.
Does that make sense?
Yeah. No, that does.
No, that does.
So and then to answer your second question, I believe, which I didn't really mark down.
Well, it has to design thinking. As an approach to solution, if you will, and whether it's possible, if you are struggling the problem, if you miss the opportunity to transcend the problem space.
So that's a very interesting question, and it's I guess I'll go back to the options field management. And
right.
The options field is in design. So what we're doing here is we're basically saying, well, what are the here's all our options and all the dimensions. Which are the most valuable? Which are the most valuable dimensions? Which are the most valuable options? How do they interact with each other? And so in the Science of Generic Design, Warfield put out just an encapsulated kind of a thumbnail sketch and said, well, look, yeah, option field management, that's a method. That's one of the standard methods of the Science of Generic Design. And he didn't really use didn't put it into the idea of generic questions or triggering questions or anything like that at the first level, just very, very high level. But what he said was that the output from the options field management has to be a linear measure. So I started thinking about that. Right? In fact, the linear measure coming out of the options field, or what we may call today something like a multidimensional trade space, I'm sure looking at it and say, well, okay, we have to have a linear measure, then we have to have a sequence. And then we have to have a sequence, and we have to have these types of relationships have to be guaranteed. And so, but do they also have to be additive, right? So, when we look at design activities, we'll look and we'll say, well, okay, I have some very important aspects. We want to be able to implement this design, and we want it to be able to meet cost, schedule, and technical or design characteristics. Well, cost and schedule are basically something that everybody's kind of familiar with. It's linear and additive scales, right? But our design scales are not linear and additive.
Right. Exactly.
Yeah. So we start looking at, once we start going from the more abstract sense of building an ISM type of logical structure, then we need to figure out which ones of these types of generic questions and triggering questions more properly aligns with our design procedures.
Exactly, and that comes back to the questions are framed.
Right. So that's the reason to develop in more precise detail the attributes and properties of these relationships. And next month we're going to produce a table, starting with relationships that are listed in the Science of Generic Design, and other ones that we've gathered from around the literature, and anything that people would like to send in to have us kind of look at and think about categorizing them. And then out of this table, what we hope to do by assigning these attributes and characteristics to these relationships, then we can start determining what methods and techniques from the classical ISM literature apply directly and very well to what types of questions.
Perfect.
And then, yeah, so that's kind of where we're going. But I couldn't get around that without somewhere we're going to have to start injecting this idea of utility theory. And utility theory, of course, in managing value. And then, of course, there's also the idea, there's term utility theory is a little bit overloaded because it's also associated with the idea of a natural monopoly, which is like utilities, water, power, phone, roads, healthcare, things like that. And so what we want to do is we want to identify one or two areas that the team has some energy behind to start actually applying these to specific examples. So we've done a lot of abstract work, the categorization and developing these attributes, but now we want to be able to say, okay, where would people like to apply these? I'd like folks to think about that, and if they have any favorite examples that would fit along the lines of social technical improvement or evaluation or design types of things.
I think yes, developing models in this relation really helpful.
Yeah, we have, let's see how to say this. In my mind, the value proposition is kind of broken as it goes through analytical procedures and analytical procedures at a large scale. Some people would say, well, you know, we have our economies and the things that we do are so large and so complex that they're simply not susceptible to analysis. They're very complex, and we simply can't deal with that type of complexity with straight analysis. You say, okay, fine, that's true, and I think that we have, from an economic standpoint, that's why we have markets, right? We have the markets out there to try to balance equilibrium, because you simply can't have an analytical dictated optimal solution.
Some people think so, but you can't. Cool.
Yeah, well, I mean, yeah. So it's just an overwhelming amount of information and control and uncertainty. You can't control everything, so that's clear. So, but but between these two boundaries of analysis and chaos in the markets, is there something in between that's useful? And so and if there's something that's in between that's useful, if we use that in a manner that increases the probability that we'll be successful. And those are the kind of questions I think that are really what we're trying to address, right?
And timely.
Yeah. Would like to be able to make a contribution, however small, if we can.
No, it's a great direction. Thanks for learning all about that. That's great.
Yeah. So, Mary, do you have any comments?
Well, yes and no.
We always have a different point of view, so
I'm struggling a little to articulate exactly how to go about addressing this without leading us into chaos. I suspect that formulating an initial table is a good way to begin.
Well, yeah, I think that's true. I mean, we've basically gone through and done this and looked at it, and developed the MEI, developed these concepts now, the characteristics and attributes. Okay, so now we're going to go back and start mapping those, and I really start circulating those, see if we get some consensus, some feeling from the community if they actually believe that this is valuable. But given that, then I think we can go back, given that table, just that table, then I think we can go back and look at the application, the structural applications that were listed in the Science of Generic Design, and then we can allocate which types of relationships or categories of relationships may be more applicable to certain types of certain ones of those application structural types. So that's the way that I think we can map that back through the classical literature. Then we come through that filter look at that. Once we've got the relationship table built, filter it back through the classical application structural types, and we can look at those and say, okay, we have these groupings of processes and methods that would seem to be the most valuable in these cases. And then we can take those and start mapping those directly to the software. Because one of the reasons to do this analysis and to keep talking about it and keep working with people on it is now to start saying, okay, well, we got this a little bit better defined, a little bit better consensus. Now we can actually apply specifically different kinds of software, because there's obviously a difference between a relationship, a structuring relationship that has a local property and a structuring relationship that has a global property. So the structuring relationship that has a global property is, in my mind anyway, is much more susceptible to implementation on software, first order logic, predicate logic, so forth. It has many more advantages. The structuring relationships that have a local attribute, well, those now they have some disadvantages. And so let's just take one of the ways of dealing with those disadvantages. The Warfield assumed that everything was transitive. Well, we need to look at that. We need to say, well, is this reasonable? What is the risks of doing that? And how do we then implement that in software? Because I believe that's a fundamental question we need to ask. Because if we say, well, it's too risky, we don't really want to do this, we want to use a different type of, and not assume that things are transitive, then we need a different type of software. So, and a software that would do different types of mathematical manipulation. So those are the kind of the look ahead to the future of what we're going to be doing in the next few months. And I kind of look forward to what's going to happen. I think Wintergreen's coming up in the middle of the month. And our next Saturday, bi-weekly meeting, I think that'll be the 19th. It'll be the first Saturday Wintergreen starts. Janet is traveling. Janet and Michael are traveling all month of August. Kevin's probably traveling too. I think he was in Greece or Cyprus or somewhere. I've been quite busy all summer, so I think that's most folks been doing that. So not quite sure about the 19th, but Janet said she would check in and let us know what's going on. And that's good to know. So I'm going to assume that we're going to do the 19th.
I think you can assume that.
Okay, good. I'll just basically put that on the chart, and I'm not quite sure who's going to present, but we'll be ready to go. Whatever happens with Wintergreen, I guess.
Yep. Okay.
Do you have any more information about what's going to happen there, Peter?
Well, I mean, I'm going. And it's
good.
two weeks, maybe 4 days, with a bit of a break. And I think the middle Saturday, and we're looking at the CBOC. And on the first week, a number of other initiatives and ideas that will be discussing.
Oh, cool. All right. They said there's something about they're going to have remote connections, and they also said there was going to be like a one-page document or something to be distributed. Are you familiar with that type of?
Yes.
The mechanics of that.
Yeah, I think I've got the one. And the mechanics of the I will pay some attention to them because I probably would help facilitate that.
Okay. Well, I'm close to the end here. So anyway, next month we'll have our focus on the relationship chart. 2 weeks will be wintergreen. See what comes out of that. And with that, I think we'll sign off with a.
Very good. Thank you very much.
Oh, thank you. Take care.
Thank you.